So tonight's chapter, chapter 12, network design. Like I said, we'll start out with network design tonight. Next week's network management, and those are the chapters that I really want you to kind of be introduced to. Gives you really kind of a good place to start on your semester projects. So the outline for tonight: introduction, traditional network design versus the building block approach. We'll talk about both of those. They used to just teach the traditional approach, which was fine in certain situations. Those situations don't occur nearly as often as they once did. So we're going to talk a little bit about it so you know what it is. We'll spend more time talking about the building block approach. We'll talk about conducting a needs analysis. You know, what is it that we need to get out of the network? What is that network supposed to do? We'll talk about the technology design. We'll talk about something that's traditionally pretty weak, the cost assessment. Especially if you're in the IS program, you usually tend to focus on the technology side of things. Unfortunately, there is a cost side of things too, a cost side of things as well that we need to look at. We need to actually crunch numbers. We need to take a financial look at a network to make sure that we can afford it, to be able to evaluate alternatives, which network design is a better deal. So it's an important idea, so we'll talk a little bit about that. We'll talk about designing for network performance, and then we'll finish up talking about implications for management. So any questions so far? Okay, so the traditional network design was a very structured approach. You sat down, you talked to all the various people that were involved, all the various users. You got an idea of what was really going on. You wanted to talk to the various people at different levels throughout the organization that used the network. Why? Because you wanted to know how often they used it. What types of applications were they using? What was the demand that they were placing on the network? You're trying to get some kind of an idea of how much capacity they're using. That's kind of the idea of going through this whole process. Based on the information that you got from that, you could then start to design, you know, how many circuits you needed, how fast those circuits needed to be, etc. Once you had all that conducted or finished, you could start doing the implementation side of things. You could start implementing that, whatever design that you happen to come up with. The problem with it is it tended to be a very long, drawn-out process. You know, a couple of years. They say it takes place over a year or two. Yeah, it could take that long or longer depending on the size of the network. As far as that approach, there's nothing wrong with that approach. You know, if you've got a small network, it's relatively easy to get the users together and be able to talk to them. There's nothing wrong with that approach. Also, if you happen to be coming into a situation where there's no network already in place, that's a good approach to take. But the reality is most of the time, you know, anymore, you're going into a place that already has a network in place. So you're not starting from scratch. There's already wires run. There's already various computers throughout the organization, maybe various servers. So you're not starting from scratch. So this approach really doesn't handle that all that well. That's where the building block approach comes from. So the shortfall for the traditional approach is that because of rapidly changing technology, it makes it really hard to go through this whole process. Why? If it takes you 2 years to implement a design, half of your stuff is already outdated. So that's a problem. Rapidly growing network traffic. We take that long to design something. Again, on the technology side, stuff goes out of date. So does our capacity. You know, we end up new applications that consume that much more bandwidth over a few years. Now we're already behind. Our designs are already out of date. And a dramatic change in the balance of costs. That's kind of shifted over the years. Traditionally, we had relatively small IT departments. Why? Because we had really big expenditures in our hardware. It was limited access to just a few people. So you didn't have a lot of people, a lot of users using your systems. The investment was really in the hardware and the software for those few individuals. Because of kind of the commoditization of computers, we kind of see a reversal of that. The cost of hardware has come down a lot, but we have to support a lot of that stuff too. So that means our cost in people goes way up. So we see a shift because of that. The building block approach basically says we recognize those shortcomings, so we want to take a different approach. We want to recognize we already have this capital investment in our hardware. in our infrastructure, in the wires that we have running through the walls, in our servers, in our switches. We want to be able to use that investment as long as possible. We want to be able to get the most bang for our buck and kind of develop our system over various iterations to get the most out of it. So we start with, or one of the key concepts is to use a few standard components. Why do we want to really kind of standardize on a few standard components? What's an advantage to that? It's a big advantage. What happens if we support Apple, Linux, and Microsoft systems? We have compatibility issues. We've got to have more people to support different systems. I mean, usually, if you have somebody that's really good, they might know Apple and Microsoft. They might know Apple and Linux. It's hard to find somebody that knows a lot about everything. It just is. So usually it means you have to have more people. So the wider variety of components that you have, the more expensive it is to maintain, the more expensive it is to support. So you really want to try to standardize on a few basic components, usually from a well-known manufacturer. Say, for example, we're talking about switches. You may want to invest in Cisco switches. Why? Because they're a large manufacturer. They're known for quality. If you get a basic switch, something that's very common, that means replacement is going to be easy. It's going to be relatively cheap. If you start going with exotic manufacturers and exotic models, the price goes up. If it fails, what happens? It's hard to replace it, or it's expensive to replace it. So try to standardize on some of those components. Start with a few standard components with ample capacity without extensive traffic analysis. So instead of placing so much emphasis on trying to analyze how much traffic we're going to be using, let's have a general idea of how much the traffic is going to be, and then build in extra capacity. We're just automatically going to assume that demand is going to go up. Why? Because it has. Ever since we started networking, we always end up taking up our additional capacity. And then phases of the design. Once we've done all this, we can start to move to the actual phases of design. That's where we're going to do a needs analysis. We're going to start to do a technology design, really at kind of a pretty high level. And we're going to start to do a cost assessment. And it cycles through that over and over again. So if you look at it kind of from this perspective, you have your needs analysis. You're going to do a baseline. We'll talk about these here in just a second. You move to a technology design, and then you can do a cost assessment, and then you start back over. So it kind of looks like a spiral that you're coming back into. Why? Because you do this, your technology design, your cost assessment, then you actually do the implementation. You've got your network. And with this existing network, you almost immediately go back to a needs analysis. Why? Because you're really talking about a 2 to 3 year life cycle of your network. You're constantly going to be upgrading all the time. So if you take this approach, it's instead of replacing everything all the time, you're just focusing on little bitty things and constantly tweaking. Let me go back a couple here. Okay, so some of the phases of the building block approach: that needs analysis, that technology design, and the cost assessment. For needs analysis, we need to understand both our current situation and what our future predictions are. It allows us to identify a gap. What are the components that will work with our needs in the future? What are the components that we need to replace or modify, add to, in order to close that gap? At this point, we can start to classify users and applications. Not all users are the same. We don't need to get nitpicky and say, this person is this type of user, that person is that type of user. We don't have to do that for every user. But in general, we want to have an idea of a normal user versus a heavy user. This one processes a lot of video, so there's going to be a lot of network demand from that type of user. Versus this one just sends email with no attachments. Very little data. You're not going to, unless they're sending spam, you don't have to worry about a lot of demand on the network. Same thing for applications. Some applications require a lot of use of the network. Other applications don't. So you want to have a general idea of the applications as well. And then you can start to identify specific technology needs. We're not talking about a brand or anything like that, but we're saying at that point you want to start to identify gigabit switches. instead of just fast Ethernet switches. Because we're processing video, we need our network to be able to process stuff much faster. So even though fast Ethernet is relatively fast, because we're talking about processing video, we really need to go something a little bit heavier with better speed. And then we can start looking at the actual technology design. For the most part, we want to look at off-the-shelf stuff. It's cheaper. It's easier to get. You can usually find it wherever you need to. You can design stuff yourself. You know, if you're that type of organization, you can get somebody to custom build you something. You can design it yourself, however you want to do that. But it drives up the cost, and that's what you're trying to avoid. In case of difficulty in determining traffic needs, provide more capacity to keep ahead of growth. It's basically take your best guess and then add some extra to it. Because no matter what you try to do in terms of predicting your future capacity needs, you're going to be wrong. The larger the estimate, the more you're going to be wrong. The further out you're trying to predict, the more you're going to be wrong. So for the most part, you're just trying to start with a rule of thumb and then build in some extra capacity. And then lastly, cost assessment. Consider the relative cost of technology. For the needs analysis, the goal is to understand why the network is being built. So you want to talk to some of the various users, not in as much detail as you would in the traditional approach, but you want to find out what is it that they want to do. Are they going to be processing video? I mean, you have to have a general idea of what some of their needs are going to be. So do you need to improve port performance? Are they having emails that are constantly bouncing? Are packets getting dropped a lot? So is that what you're really trying to do? Are you trying to enable new applications? Do you have users that are Skyping a lot, for example, or wanting to Skype? Are you trying to upgrade, replace old equipment? Maybe it's just old and outdated and starting to fail. Standardize equipment based on vendor or protocol. So maybe you've, over the years, acquired various other businesses that use other equipment, or that use Novell networks instead of Windows networks. So you're trying to standardize on a single type of technology or single type of operating system or server system, and usually along with that comes standardizing on protocols, TCP/IP as opposed to IPX/SPX. Any questions so far? So at this point, all we're trying to do is figure out what our current situation is and where is it that we want to go. Where is it that we want this network to be able to get to be able to serve our needs in the future. Goals differ depending on the network. A LAN or backbone network is typically built with organizational ownership. What do we mean by that? Take a stab at it, somebody.
I think it would stay within that company, that would be the only users of it?
Yeah, they've got organizational ownership. They're the ones making the investment. It's their money that once they spend it, it's gone. So it's the type of situation where if we're going to spend this, we want to spend more and get that extra capacity because it costs a lot more to come back after the fact and upgrade. So we want to build in enough extra capacity so that we don't have to come back and upgrade anytime soon. When we talk about larger networks, usually our WAN connections or a MAN connection, we don't usually control that network. We're usually leasing those lines. Well, when we're leasing lines, it's much easier to add or get rid of capacity because we're just signing agreements with MCI or, well, maybe not MCI, AT&T or Sprint or whoever. So we simply add capacity that way or reduce capacity that way. But when it comes to our LAN, it's much more difficult for us. It's easier for them to be able to do that because they've got so many customers. At that point, once we've done this needs analysis, we can start to do a baseline. The baseline is what we're going to take of our existing infrastructure, our existing system. It gives us a place to be able to measure our improvement once the new system is in place. We want to know we're trying to increase our bandwidth, for example, X amount. Well, we we can't determine that we've increased to X amount if we don't have a starting place. That's what baselining is. It's figuring out where we currently stand. So gain an understanding of the current operations in terms of application systems and messages. So go out and look at the applications that are currently installed on the servers, various clients, things like that. They talk about most projects today involve upgrades and not new networks. It's true. I mean, you think about virtually every business you go into, even the small mom and pop stores, they have networks in their facilities. But it allows you to create that baseline and allows you to make a comparison on the performance before and after you've upgraded that particular network. So it gives a clear picture of the sequence of operations, processing times, etc., work volumes, the current network, existing costs, etc. The objectives of the needs analysis: define the geographic scope of the network. How big is your network? This is where you're starting out trying to figure out what is the scope of your network from a geographic perspective. If it's a small business, it's probably one building, maybe a couple of buildings. If it's larger, it may be spanning multiple buildings. It may be spanning across town. Obviously, it could be much larger than that. It could span the country, the state of the country, or even globally. The goal for this at this point, you also want to define the application and users. The goal is really to start to produce an actual design of the existing network. So you're trying to produce a logical network design that describes the network elements that are needed. They're needed to meet the organization's need. It doesn't talk about the technologies again. At this point, you're just saying this is a general outline of the network that we need. So you might see something like, well, it's too far down. We'll get back to that in just a second. So the first step in the needs analysis: break the network into 3 conceptual parts. Most small networks are just going to be at one of these layers. It's not until you're really talking about a fairly large organization that you're going to be talking about the core layer. But it's basically different layers, different levels of abstraction of how you want to look at an organization's network. So for a small business, they may just be operating at an access layer. That's the part of the network that's closest to you as a user. That's where you see the individual computers, the wires that are tying them together, the switches, and maybe a link to a WAN connection. The distribution layer is a little bit larger in scope. It may be for a larger business where you may have multiple buildings together. So you may have some need of some type of backbone network to tie together multiple LANs. And then a core layer is even larger in scope. Again, you may be trying to tie together multiple backbone networks. So if you're a large organization, you may be operating at all 3 layers. But for the most part, if you're a smaller organization, you may only have 2. You may even only have 1. So when you think about that, that's what kind of gives you an idea of where you can start on designing your network. If you're a large organization, you probably want to start at the core layer and work your way down. It's a top-down approach. So what it says down here at the bottom: not all layers present in all networks. Small networks may not have a distribution layer. Next step in the needs analysis: goal is to produce a logical network design describing network elements to meet the needs of the organization. So you want to identify some of the basic technical constraints. So, for example, if the access layer is a metropolitan area network, the users need to use broadband. That's what you're talking about, their connection to the wide area network. If it's a LAN, there's no need to use T1 lines. We're talking about Ethernet. We're not talking about a connection to an uplink or anything like that. Identify constraints imposed by the current network infrastructure. So adding a new building to an existing office complex that uses 100 base T, maybe you want to use the same type of technology. Maybe you don't want to come in and install fiber optic because you want that network to be compatible with the existing network. At the same time, it may be an opportunity to upgrade the existing network. Maybe you do install fiber optic because you want to upgrade the existing building to fiber optic. So you need to balance the needs of the organization with what makes sense. But you want to make sure that you're trying to, the compatibility is one of your primary concerns. And then you can get into the actual design process. Start with the highest level. Again, start with how it's coming into your network, so your WAN connection. So you want to start at that level of abstraction. So it's basically your building, your business, your organization, and how you're going to connect to the outside world. and then you can start to drill down from there. If you've got multiple buildings, how are those buildings going to be connected? Within those individual buildings, how are your various computers going to be connected? Various floors, how are those floors going to be connected? So then you can basically go through that whole process. You also want to keep in mind legal requirements and regulations. If you're talking about starting up here at this highest level, you may have certain legal requirements. For example, if you're tying together different buildings, one building on this side of town, another building on another side of town, and you don't want to lease lines, you might use microwave, for example, to be able to tie those two buildings together. To be able to do that, you have to have some kind of tower. So those microwaves is a line of sight technology. So you have to have the two towers so that with the transmitters and receivers pointing at each other. To be able to do that, they have to have towers that are high enough to be able to, so they can see each other. Well, there's usually, inside a city anyway, there's usually certain restrictions that say if you've got a tower, it has to be so, depending on how tall it is, it can only be so tall. And depending on how tall it is, it has to be so far away from various structures. So you have to be aware of some of those types of regulations when you're talking about that. Once you start to get down to the smaller level, so that you're talking about your various computers inside that facility, you don't usually have to worry about that. But every now and then there's something that kind of creeps up on you, so you do have to be aware of some of the local requirements and regulations. So this kind of gives you an idea of what some of those different layers, how those different layers might be tied together. If you look up here, this is probably the simplest one, where you've got a little access layer. So it's probably just a local LAN. That may be a room, that may be the floor of a building, something like that. And there's another, in this case, a MAN here, and they're tied together at the distribution layer by a backbone network. That's what ties those two networks together. But what ties all these different backbone networks together is this core layer. So that's that highest level of layer of abstraction. So this is a pretty high level of abstraction. We're not looking at a local area network with all the different PCs, the type of building, things like that. Any questions somewhere? Okay. Application systems, baselining. Review the applications currently used on the network and identify their location so they can be connected to the planned network. Again, we do a lot of baselining because to know how far we've come, we've got to know where we started. So you want to know what those applications are that are already installed on systems, and you want to see how they perform across the network. You want to know where they're installed, because it may, in order to increase performance, you may find, and we'll talk about this a little bit more at the end of the chapter, you may find that one of the ways to increase performance, you don't have to do anything other than move a server, move the location of an installation closer to users so they're not tying up as much bandwidth going across the network. So you want to be aware of what applications are on the network, but also where they are on the network. It doesn't make sense to load an application from an office that might be in Europe if it's predominantly used by users here in the United States and you already have servers here in the United States. So those are some of the things you want to look at. Include applications expected to be added to the network. Review long and short range plans, goals, development plans, and strategic directions for the organization that will impact the network. So what applications are you looking at adding to the network? What types of demands are those going to have, those applications going to have on your network? Hopefully you have the opportunity to kind of play around as a network administrator, to play around with some of those applications so you can kind of get a feel before you actually push this software out and have everybody using it. Also identify the hardware and software requirements and protocol type for each application. The last thing you want is to have some kind of application that requires IPX, SPX when you're on a Windows network. You don't want to do that. And for the most part, you're not going to run into that situation. But every now and then, you will run into a specific application that you need that runs on Linux, for example, and it hasn't been ported to the Windows environment. So you're going to have to accommodate that. Do you want to put a different protocol running on your particular network? That's something you have to consider. And you also want to look at your network users. Assess the number and the type of users. So how many users do you have? And kind of categorize them in a broad sense, like I was talking about earlier. Heavy users versus light users. What are the general characteristics? As far as the heavy users, is that throughout the day? Do they just do it at the end of the day, the beginning of the day, during lunchtime? How is their use spread out across the day? the network traffic comes from internet use, things like email, www, just casual surfing. That's really starting to change. Even though a lot of it's through web applications, you're seeing a lot of it from YouTube and Netflix, things that are high bandwidth type applications. So they're still coming across HTTP, but there's specific applications, they're specialized applications within a web browser that are really tying up a lot of bandwidth. Future network upgrades will require understanding of the use of new applications, things like video on the network traffic. Then we can start to categorize network needs, assess the traffic generated in each segment for each application and user. So based on an estimate of the relative magnitude of network access, typical versus high volume, I personally would probably tell you to focus on the high volume side of things. Why? Because for the most part, we realize that by the time we get an actual design implemented, that some of that excess capacity that we designed into the system is already going to be being consumed. That's how users are. The more bandwidth we give them, the more they take. Can be problematic with the goal is a relative understanding of network needs. Multimedia applications have high volume, financial apps do too. Organize network requirements into mandatory, desirable, and wish list requirements. Why? Because we've got to take this design, this proposal, to management, right? Management's going to say yay or nay. We've got to have some kind of a list of the various types of network upgrades that we're going to plan on implementing over a year or whatever our cycle happens to be, so that we can say, okay, these are the ones that we have to get done. Why? Because if we don't, our network's not going to run. We're not going to have a job if our network doesn't run. Versus desirable, these are ones that would be nice to have, but, so if we have any extra money left over, those are the ones we want to do. And then we got wish list ones, which almost never get done, unless there's just, some kind of windfall. We'll talk a little bit more why that is the case here in a little bit. Enables the development of a minimum level containing mandatory requirements if cost is a constraint. It is. Cost is always a constraint when it comes to the network budget. Again, why? Because we have almost demand growing at an exponential rate versus a budget that grows linearly. Deliverables, a set of logical network diagrams showing applications, circuits, clients, servers. They say network diagrams. What they're talking about, diagrams, lists, tables, figures. You're really talking about some of the stuff that you'll be able to see in that sample document. Some physical design. So you may see something that looks very familiar if you're familiar with drafting. You may see a floor plan with various circuits that are described on there, locations of computers. And again, that's just that level of abstraction. There's different levels of abstraction for a small network. And ultimately, when you actually get down to the implementation side of things, you need to have that very detailed level of abstraction to be able to show what's being installed where, things like that. Categorized as typical or high volume, some of those circuits. Logical plan, conceptual plan for the network. Again, you're not talking about the physical elements again. You're still not saying this is a Cisco switch, this is a Dell computer model, such and such. You don't need to get to that level at this point. So you may have something along these lines. You get your a general floor plan of the building, the various areas where you might have a LAN here, typical use, a LAN here, typical use, same thing here, same thing here. This particular one happens to be high traffic. Why? Maybe it's some kind of media office or something like that, so they're doing a lot of video or pictures or something like that. And then just kind of a campus core backbone. As far as applications, you see down there, they don't have the desirable one in their list there, but they have mandatory in their wish list applications. So mandatory, they have to have a file server. That's what they want. Centralized storage of files. It makes sense from a network management perspective. We want one location to store all the files so we can back them up appropriately. That just makes sense. So mandatory, a mandatory application. A mail server, as an organization, you have to have email anymore, so they're saying that that's mandatory. And a web server, they're saying is mandatory. Their wish list is desktop video conferencing. If you're a larger organization where you spend a lot of time out in the field, doing sales calls and stuff like that, maybe that becomes more of a priority, to reduce costs for traveling and stuff like that. But at this point, for this particular organization, they're saying that that's a wish list item. Any questions? Okay. Technology design, development of a physical network or set of possible designs. This is what I was talking about earlier when I said the project that's posted online, that's probably one of the weak spots in that particular one. They had a design that they came up with, and they did a financial analysis for that particular design, but they didn't provide alternatives. So, I mean, ideally you'd have probably 2 or 3 different alternatives, which means 2 or 3 different designs, and then you could make a comparison. Okay, we can get this X level of performance for this cost for option A, this level of performance and cost for option B, and this level of performance and cost for option C. You can take that to management and say, okay, which one do you want? And allow management to make that decision. At this level, you can specify the computers, clients, and servers needed to support applications and users. You can specify new computers and upgrades. A lot of times, you don't have to do that if this is an existing network. A lot of times, you want to use the computers and stuff that's already there. This is certainly the best opportunity to add new computers if you need to. It's certainly the best opportunity to upgrade computers if you need to. But in a lot of cases, if you're GM, you don't just at a whim upgrade 10,000 computers. You try to cycle those things through. Specify circuits and devices. This is largely what you're doing for an existing network. Is you're specifying the circuits, the type of routers and gateways and stuff like that you're going to connect things to, the type of cabling, etc. Designing clients and servers. Building block approach requires the specification of the computers needed in terms of standard units. Again, it's the idea of trying to have just a few different designs in order to reduce your costs. You can buy in bulk, for one, but you also reduce a lot of your maintenance costs. So if you have only a couple of different kinds of computers, it's much easier to be able to maintain those computers, so your support staff doesn't have to be nearly as large. Unfortunately, that doesn't always work out the best for everybody. Every now and then you'll have a user that's really picky and they want a particular application. Well, if the help desk doesn't support that, sometimes that can be a problem. So there's a certain level, or a certain degree of politics that goes into this as well. How rigid you want your network management to be versus how standardized or how friendly do you want it to be. I've been in both environments, and honestly, the more rigid was actually probably the best. In my personal experience. It could be frustrating at times because you weren't allowed to install your own software or anything like that, but at the same time, they turned over their equipment very often, and so you constantly had the best equipment that you could have, and they were able to do that because they had a very small support staff because the equipment was all standardized. So you have base level computers, and you might have advanced level computers for power users, for example. And then they say, beware of the definition for a typical unit. It keeps changing as hardware costs continue to fall. So just because you call it a typical unit today, if it's a typical unit today, that means a typical PC, it's out of date tomorrow. That advanced computer today is a typical one tomorrow. So those definitions are, it's kind of like nailing jelly to the wall. The definition's going to change. It's not going to stay the same. Designing circuits and devices. Deciding on the fundamental technology and protocols. So at the local area network layer, what are you going to use? Are you going to use Ethernet? The vast majority of the time, the answer is yes. It just is. There are other technologies out there, and we'll talk about those. Excuse me. We'll talk about those when we get to that chapter. There's Token Ring, for example. There's Apple Smalltalk. There's a few different types of protocols that are out there, but really, for the most part, we've standardized on Ethernet at that layer. Now, at the network layer, we've kind of network and transport layer, we've really standardized on TCP/IP. So for the most part, that's always what you're going to pick. Not always. If you happen to be on a Novell network, an old one, you're using IPX, SPX, and there's others out there as well if you're having to interface with a mainframe, for example. But for the most part, you're going to be focusing on TCP/IP, so it makes sense to learn the most about that. At this point, you can start performing capacity planning, estimating the size and type and standard and advanced network circuits for each type of network. So for your LAN, your backbone network, your WAN. So how fast are you going to be? Do you need your network to be? For the most part, they put up 10 megabits per second. For the most part, you don't have to worry about that. I doubt you could find any 10 megabit equipment out there anymore. But you can definitely find 100 megabit versus gigabit Ethernet out there. 100 megabit is perfectly fine for most applications. But again, if you're going to be talking about a lot of video, a lot of heavy duty, or a lot of users, you probably want to go ahead and up it to 1,000. Why? Because for the most part, the cabling that you're going to get is going to be able to work on either one. So that's going to be irrelevant. The differences that you're going to be looking at are going to be in the switches and in the network interface cards. So that's where you're going to see the real difference. Assess current and future circuit loading. The amount of data to be transmitted on a circuit focuses on either average or peak circuit traffic. Again, I would focus on the peak circuit traffic. Why? Because once it's implemented, between design versus implementation, you already lost time. The demand for that capacity is already increasing. You need to be planning at the higher end. Estimate the size and type of standard and advanced circuits for each LAN, backbone network, and WAN. Any questions yet? Estimating circuit traffic, average traffic versus peak traffic. It may be the number of emails that get sent out per day, or maybe you put a packet sniffer on the network so you can actually measure the number of bytes in a day. There's a variety of different ways of actually doing it. To arrive at some kind of figure for peak traffic, you're going to have to do it over an extended period of time to really kind of get a good idea. But usually you can measure traffic in a variety of different ways and get a general idea as to the pattern of traffic. Again, number of emails or websites visited. You can get some kind of metric. And then based on that metric, you look at your existing bandwidth, and you want to project out some kind of growth into the future. So we'll talk about that growth here in just a second. So you want to estimating message volume, count the number of messages, multiply it with some kind of growth rate. You could use a packet sniffer if it's an existing network. Precision is not the real concern. You're not trying to figure out exactly how many bytes or exactly how many messages. You want to know the magnitude, so a general term of how much the network is actually being used. As far as your growth rate, typical rates that you want to look at, and on the 5 is really low, and it sounds kind of high on the high end, but 5 to 50% as an annual growth factor. Some people use 100% growth factor. If we build it, they will come. That's kind of the way network bandwidth works. So the cost of extra capacity versus the cost of upgrading a network, it costs a lot more to build that capacity in and then have to come back and upgrade later, rather than just have that extra capacity in there in the first place. So you're better off having, instead of having to pull, if you install older wire, you install Cat 5 wire, for example, instead of 5E or Cat 6 cable. It costs you a lot more to come in and have to pull that old cable out, install a new cable again behind walls that are already there. So it's a lot easier just to have the better quality wire up front. So most organizations intentionally overbuild. Most end up using overcapacity within 3 years. So again, 3 years is not very long. So you want to have that extra capacity built in. There's this idea of the turnpike effect, which is what I've been talking about. If you build it, they will come. If you've got that capacity, somebody's going to use it. They just are. So how do we put all these diagrams together and all that kind of stuff? Well, there's a variety of different tools that are out there. Some of them are more user-friendly than others. Visio is one that a lot of people are familiar with. It's a good diagramming tool. It's part of the Microsoft Academic Alliance. Did you guys get that email yet?
Mm-hmm.
You did?
Yes, I did.
Should be to I think your Go account.
Yes.
Okay. It should have instructions on. Did you get it?
What is it called? Dream? Is it Dream or Dreamworks or something like that, right? The email.
It might be. I'm not sure. I haven't actually seen the email.
Software.
Yeah, it's for free software. It should have been automatically generated after the ad drop period. Check your Go account, your Go Tarleton account, because I think that's the account they send it to. But Visio is part of that, and it's a good diagramming tool to be able to create your buildings, to draw your various circuit connections, to be able to include the things like routers and switches and your various computers and servers as well. It's a nice tool because it's very formal, it's very easy to use, it's drag and drop and all that type of stuff. And in the higher end version, the professional version, it's a lot more customizable. It has some actual equipment in there, so if you have a specific Cisco switch, for example, you can use that switch in the diagram, and it knows the various features of that particular switch. There's some other tools, though, that actually are discover-oriented. They actually hook up to the network and will go out and identify the network for you, the existing network that's already there. So you don't have to start from scratch. It automatically says, okay, this is a switch, this is a hub, this is a router, these are the various computers that are plugged up, this is a network printer. And so you start out with a diagram that's kind of pre-done, pre-made. And it allows you to much more quickly begin diagramming your existing network and then be able to add or augment the existing network. Once the diagram's complete, add information about the expected network traffic, so how fast some of those circuits need to be, for example, how much you anticipate the demand to be for particular circuits. As far as trying to anticipate some of that demand, you can go through the process of simulations, but unless it's a sufficiently large network where you expect there to be high demand or you expect there to be certain issues with respect to demand, a lot of times it's not worth going through the process. The simulations aren't as easy as they sound. Like you hear simulation and you think the nice graphic stuff and all that kind of stuff that you see in science fiction movies and things like that. But when you're talking about these types of simulations, you're really talking about they're very mathematically based. Sometimes they're hard to code a lot of the criteria, for one, and interpreting the results is sometimes difficult. But simulations can be used really to try to anticipate some of the problems that you might have in a larger network. For example, you might be able to simulate what happens when a particular switch fails. Where do the packets go? What does that do to the performance of the rest of the network? So simulations can be valuable in certain situations, but unless it's that type of situation where you really need to be aware of the various faults, like a government-run installation or an e-commerce installation where you can't afford for it to go down, a lot of times that's kind of overkill. Once the simulation is complete, examine the results to see estimated delays and throughput. Change the design if necessary. If you change the design, you really need to rerun those simulations. Why? Designs change. You hope the results would change as well. Maybe you go back to the original design. And this is what we were just got through talking about. So the deliverables at that point, you've used a discover-driven tool, or you've used Visio, so you should end up with a set of physical network designs with general specifications for the hardware and software required. Again, at this point, you're not talking about a specific brand and model, but you are starting to say, okay, this is a 16-port switch that we want installed at this particular location. And you want to provide alternative designs so you can do a cost analysis of cost versus performance. Again, that's at option 1, option 2, option 3. We have different designs that we can compare both in performance and cost. Why? Because we're just network designers, we're just network managers. We're going to let the suits make the decision. Pass the buck that way if something goes wrong. As long as everything we did is right, they're the ones that made the decision. The crucial issue is the design of the network circuits and devices. That's where we're going to spend most of our time in an upgrade situation. If it's a new network, we're going to spend more time looking at the clients and the servers and things like that. But if it's an upgrade, we're going to be looking more at the circuits and where the circuits are run, those types of things. So it really depends on where you're going to focus on whether or not it's a new network or it's an upgrade. So again, it's a little bit more specific here now when we talk about these connection points. It's a specific kind of switch. It's in this case, a fast Ethernet switch versus a gigabit switch. Cost assessment. Assessment of the cost of various physical network design alternatives. 1, 2, and 3. What are your options? Unfortunately, for a lot of network managers, I was working at a place when they were going through the process of trying to evaluate some upgrades, and they were trying to figure out what were they going to do with the old equipment? How are they going to manage the process so that they get all this new equipment, but they dispose of the old equipment in the best possible way so they can get money back for it, so that they're not paying top dollar for everything that they're buying. And so they want to be able to offset some of those costs. And so you have to spend a lot of time. You're talking about people that are not used to that. They're having to deal with numbers, money, rather than IP addresses and stuff like that, where they tend to be more comfortable. But it's something that you have to be able to do. You have to be able to sell that design to management. And so you have to analyze all these costs, things like the cost for the various circuits. Now, when you're talking about the cost for the circuits, internally you're talking about the cost for the wires. The cost for the wiring, the jacks, all those types of things. Externally, you're talking about the cost for a lease for a particular line, a T1 line, or DSL, or cable, or whatever it happens to be, your WAN connection. Internetworking devices, your switches, your routers, that kind of hardware. Other hardware costs, your servers. In a lot of cases, you don't have to worry about network interface cards. They're built into the motherboards in most situations anymore. That's not always the case, but it's something you have to be aware of. If it's not built onto the motherboard, you got to be buying NICs. So you have to be aware of that. And then UPS is something that will help protect you in case you lose power, helps protect the equipment. And so you got to consider those costs as well. Then there's software costs, the operating systems, your applications, any middleware that might be required, especially if you have older applications. You might have to have some kind of middleware to let applications talk to each other. Network management costs.
Sorry, what's middleware?
Middleware is a type of software that sits between two different pieces of software that don't play nicely together. So, for example, you may have an old application that you can't get rid of because it's got too much data in it that's too important to you, but you've got a new piece of software that you really want to use. Well, you can usually apply some form of middleware that will take the data out of the old application as needed, convert it so that the new application will understand it. So that middleware sits there in between, does that translation for you. In a lot of cases, it's stuff that has to be custom written. Good question. Anything else? Let's see. Network management costs, including special hardware, software, and training needed for network management. Believe it or not, all those geeks that sit back in the server room don't know everything. The IT shop that I worked in, they were very good at what they did, but one of the reasons that they looked as good as they did was whenever they got a new piece of software, they got a new piece of hardware, they all huddled up over in a little corner and played with it, broke it, and figured out how it worked. They didn't know either. But before they ever went out and talked to users about it, they worked with it first. So they never wanted to go out to users and say, well, let me figure this out. They wanted to already know before they ever got out there. So when they're back in their shop, that's where they would learn about how it worked, how it didn't work. So you've got training that goes on. Those are costs, special hardware, software, etc. Test and maintenance costs for monitoring equipment and supporting on-site repairs. A lot of times you buy a new server, you get a maintenance contract with that. Take advantage of it. But a lot of times you can extend that maintenance contract by paying extra money. But that's a cost to be aware of as well. And then operations costs to run the network. It costs electricity. Plug in a switch, it draws power, there's costs. Data centers, I don't know if you read it in the trade publications, but data center costs are really expensive. Why? Because there's so many servers, there's so much cooling going on. They're really, really expensive. To the point that I actually read a story. There's a company that is trying to set up data centers in the extreme cold areas in Sweden and places like that, because there's a natural cooling effect, obviously. So if they can help reduce some of their expenses. Request for proposal. So we've got all this stuff. We've figured out our costs. We've designed our system. We've got everything figured out as far as what we want to a large degree. We think we figured out costs, but now we actually got to go out and make a purchase or find out what the actual costs really are going to be. One of the ways we can do that is we can go to vendors and instead of doing it ourselves, we can go to vendors and say, tell us how much it's going to cost. Give us some insight into any of the designs. Here's our requirements. What do you have in mind? What do you think might work better than what we've come up with? So, especially in a large type purchase, it doesn't really make sense to do something like this. Most vendors aren't going to mess with you if you only have a few computers to buy or a few things to buy. But in a large purchase situation, vendors a lot of times will bend over backwards to try to get your business because you're purchasing so much. So if you provide them with detailed specifications of some of the equipment, some of the software, some of the requirements that you have, a lot of times they'll work up an estimate for you. So you've got to give them a lot of information. Why? The more information you give them, the more accurate their quote's going to be, the more specific it's going to be. If you give them just vague specifications, they're probably going to give you a pretty broad range as far as the cost because they're not going to know for sure. So you want to give them a list of your mandatory versus desirable or important items. Some requests for proposals may simply list requirements with no specific equipment. Maybe you leave a lot of that up to the vendor. Why? The vendor a lot of times does this all the time. They may be better at it than you. So in some cases that may be something you want to do. Ask the vendor to provide their proposed design if asked specific items at best prices. Always ask for best price. Maybe that is their best price, maybe it's not. But if you don't ask, you're not going to get it. Allows apple comparisons of numerous vendor responses. I don't know that I agree with the author so much on that one because a lot of times if you're getting feedback from a vendor, if they've tweaked any of that stuff, it's different than what you originally gave them. So you may not be getting back a proposal or an RFP from them, a response to an RFP from them that's directly comparable to responses from other ones. Maybe you will, maybe you won't, but that kind of depends. As far as the general outline for a request for proposal, you need to give them some kind of background information about the organization, what you do, what you sell, what are your requirements, things like that. Your network requirements, choice of possible network designs. Again, they may propose an alternative. And if it's something that they do all the time, maybe their alternative is better. Maybe they can do more with less, so to speak. Your service requirements. Is this something you have to have up and running in the next 90 days? Because if it takes them a year to do it, it's probably not going to work very well. You also need to let them know what the bidding process is. Is it open bids or is it closed bids? Are they going to be able to see what other vendors are bidding, or are they not going to be? So you need to kind of lay the groundwork for that up front. And then any information required from the vendor. You want to know, is this a trustworthy vendor? Is this a vendor that's been around? Have they done other projects like this? Because if this is their first one, you would probably anticipate a lower price, but you'd also probably anticipate problems. They haven't done this before, it's their first time. They're going to have to work out some of the bugs. So, maybe there's a trade-off there. Vendor selection process. Evaluate the submitted proposals against specific criteria. You want to have that criteria down up front. You want to know what's the most important. How quickly they can get back with you. How quickly they can implement this a possible solution. Cost. Maybe you want to weight these various things. Maybe cost is a really big deal. So that's 40% of your weighting criteria. The time, maybe that's less important. It's only worth 10%. And then your various other criteria. You want to have those in place before you ever start this. Why? So you're evaluating them with a fair set of rules, a fair set of standards. You're not giving weight to, well, we like these people more, or he took our salespeople out to lunch or something like that. You want these criteria in place ahead of time. So select those winners based on criteria. At this point, they start to talk about using multiple vendors. And there's pros and cons to multiple vendors. If you use multiple vendors, a lot of times you can get exactly what you want. One vendor is not going to carry everything that you want. So using multiple vendors, a lot of times it allows you to get various devices that you want that are exactly what you want, better pricing sometimes, things like that. The downside to using multiple vendors is if you've got multiple vendors and there's some kind of compatibility problem, what always happens? It's not our stuff, it's their stuff. And so you go talk to them, it's not our stuff, it's their stuff. And you go back and forth. Sometimes it's really hard to get problems resolved when you start talking about multiple vendors. But in some cases you can get better performance. Why? Because you're getting the equipment, exactly the equipment that you want. Sometimes you can get it for less price. But there is that manageability issue that pops up sometimes. Selling the proposal to management. How do you get those people to crack open their wallet and pay for this stuff? Well, unfortunately, it's kind of hard. Why? Because in most cases, your networks don't make you money. If you're Amazon, your network makes you money. But that's, Amazon's kind of a rare animal. For the most part, network's a cost center. So whenever network comes to management saying we need money, they just shake their heads and they don't want to give you any more money. It works good enough. We don't want to spend any more money on it. So you've got to really try to sell network performance to these individuals. You want to speak in a language that they can understand. If you start talking about gigabit switches and bandwidth and throughput and stuff like that, network interface cards, they're going to get glossy-eyed. They're not going to know what's going on. You want to start to talk to them about, we can respond to this many more e-commerce transactions. We can, things like that, things that directly translate into some type of monetary value, things that business people understand. So you want to make a business case by focusing on organizational needs and goals, such as comparing the growth in network use with the growth in network budget. So growth in network use typically is exponential versus the growth in budget is typically linear and a very slow growth rate at that. Avoid focusing on technical issues such as upgrading to gigabit Ethernet. They're not going to know what that means. Faster versus slower. That's what they're going to understand. Focus on network reliability. Again, if we're up 99.999% of the time, 5 nines, that's a good thing. That means we can serve customers more. That's what you're trying to sell. Not that we can respond to web requests and that we can be online a lot. You want to translate that be online a lot to sales, something that they actually understand. So the deliverables out of this stage, a request for proposal issued to potential vendors for their reply. Hopefully you get a reply. Maybe you do, maybe you don't. You never know. Can be tied to a contract with a selected vendor. Revised set of physical network diagrams. You go through this whole process, that vendor may come back with you and say, okay, we've got a better design. So you may have to go back and revise the design that you originally came up with because they may have a particular switch that has more ports on it. So it changes your design of where you're going to run wires, where you're going to run circuits. But that's going to be done after the particular vendor's been selected, after you start to pick specific technologies, specific types of switches, etc., and then the selected components. And then another deliverable is the business case to support the network design. Why are you doing this? What is it? It's basically taking what we talked about just a second ago. It's taking all that stuff that you were trying to do to management and putting it down in writing. What is the business case? How is this going to make the business money? So it's expressed in terms of business objectives.
So what's the difference between an RFP and a business case? Because an RFP also has lists on like costs and all that, right?
An RFP is a formal document that you're going to give to a vendor. The business case is really kind of more of an abstract term that you're going to be delivering to the powers that be within your organization. So to get them to open their pocketbooks to pay the vendor for their hardware, software, their expertise, or wherever it is you're going to get your goods and services from, you're trying to get them to make that investment. So the business case is something you're presenting to management. The RFP is a formal document that gets presented to a vendor and for them to get back with you and say, okay, these are the products and services that we offer. This is what we would suggest as far as the network design. And then you can kind of work in tandem back and forth that, this is the design they came up with. well, we really need this. And you can go back and forth and narrow it down. But that, again, that's going to be reflected in the price as well. So it's really where it's directed to. The documentation is different, but the target is different. Is the biggest part of that. Designing for network performance. Several higher level concepts used to design network for best performance. We've got this idea of managed networks. Managed networks is something that takes a little bit more work. It's a different type of equipment, but it gives you certain features, certain advantages that you have that you have over unmanaged networks. With an unmanaged network, that's typically what we would have at home. You have a switch, you have a router. You do very little to it, especially if you get a switch. You plug it in, and it just works. A managed device, however, will, depending on the type of management that's built into it, will provide you with certain information. It may say, this port is getting a lot of bad packets sent to it. That means whatever's plugged into that port probably has a bad network card, a card that's starting to fail. What does that mean? Well, that starts to tell the network administrator that this card is starting to fail, but it hasn't failed completely. You know that a card's about to fail before it fails, potentially before the user ever knows it fails. You might, if you have somebody shows up to replace your network card before you ever know that the card's failed, that's kind of weird, but it can happen. Managed networks allow you to apply policy-based management. So, for example, you may not allow certain types of traffic to occur at certain times of the day. For example, if you happen to live in a dorm, the managed network may not allow video sharing or video files to run across the network during the day. At night, it's okay because there's less demand on the network, so we'll allow it in the evenings, but not during the school day. That's some of the advantages that policy-based management and managed networks allows you to do. Something else you can do as far as performance, you can use traffic analysis and service level agreements for your network services. So, for example, you can analyze the traffic analysis in order to make sure that your service level agreements are actually being met. So if you're not getting the performance that you're supposed to, you can go back to your whoever's providing your WAN access and say, hey, look, you're supposed to provide us with 2 megabyte bandwidth downstream. We're only getting 1.8. Our service level agreement says you pay a fine. When that's the case, you need to pay your fine. But you've got to be able to measure it to be able to do that. And then network devices also allow you to determine device latency and device memory as well as do load balancing. So if you've got demand that's occurring on the network in certain parts of the network with load balancing, you can shift it to other parts of the network. A lot of times that happens with caching, for example. You might have a proxy server at the gateway of a particular network that allows you to cache websites as they're accessed internally into that network. The advantage to caching those websites locally is that the next time a client has to access that same website, it goes to that proxy server, and if there's a cached copy of that page, it simply returns it. It's much faster. It doesn't have to go out onto the WAN that way, so you're reducing your WAN use, potentially your costs on the WAN. So it's a way to speed up performance and reduce capacity. So that's something that you can do to improve your performance. And minimizing network traffic, content caching, and content delivery is what I was just talking about. Managed networks that use managed devices, things like switches and routers can be managed. Monitors the flow of traffic, monitors its status and other devices connected to it. So again, do you have a network card or a port on a switch that happens to be failing? A lot of times you can identify that beforehand. Records various data on messages it processes. You can start to determine if a network segment is getting congested. So maybe there's too many clients on that particular segment. You need to segment that out so that it's more than one, so you don't have every. So say, for example, this entire room happened to be on a single segment, and we were using a packet sniffer to look at any of the problems, or we had some type of managed network that was paying attention to the traffic that was going on. And all of a sudden we recognized that there was a lot of congestion going on. Well, maybe we determined, okay, we need to break it into 2 segments. So even though they're physically in here, they're logically on two different segments, so you don't have nearly the congestion on each segment. And the real advantage on a managed network is they can send out alarms. So there's a variety of different ways, and we'll talk about in the next few slides. There's some protocols that exist for managed devices that allows them to communicate with the server and really kind of serves as a dashboard for a network administrator to be able to understand what's going on their network at any point in time. Some lower end devices actually have stuff similar to that built into it, but instead of using those standard protocols, they'll simply email a message. They'll have a little SMTP server built into them, and they'll send out an email message that you configure in that particular device. For example, I've got a little NAS device, a network attached storage device. You can input your email address into it, and when the hard drive gets full or if the hard drive starts to fail, it sends out an email message that says, you need to check this hard drive, it's got a problem. So that's kind of a poor man's version of a managed device. So when we're talking about at the larger scale type devices, usually it's going to require hardware and software. The hardware are usually devices that are built, or parts that are built into the hardware. So it's a special switch. It's not one that you're going to go buy at Best Buy. And then software, where you're going to be able to organize that information that you're getting back from those various managed devices. You're going to be able to store it, analyze it, and look at it so you can see how your network's performing. That device management software provides specific information about the device, analyzes patterns of configuration, traffic, error conditions, etc. So you can make sure, using this software, all your various switches are configured the same way, that you don't have any inconsistencies in your various configurations. You can look at the traffic. You can start to see some of those errors and highlight those errors. So again, so you can start to identify a problem before users really understand that it's going on. System management software or enterprise management software analyzes device information in our record for diagnosis, prevents alarm storms for a failure on a circuit, many connected devices sending alarms. A lot of times when you have a failure, what happens is a single failure propagates throughout a particular segment and looks like failures coming from everywhere. And good software and good hardware will actually be able to sift through that and identify the source of the original error. So that instead of getting bombarded, again going back to my example with an email address, because it's probably the simplest to understand, that instead of being bombarded with 10,000 emails, you can go back to the original problem and actually just get that one email that this is the actual problem. Even though all these other ones look like issues, all those issues are stemming from that one initial problem. So that's what some of the software can allow you to do or help you to do as a network manager. Application management software monitor applications based on device information, focus on delays and application layer packets. So this is just kind of some examples, some screenshots of some of the software. This looks like it's from the university. Actually, it is. The second author is at Indiana University, and that looks like some of their software that kind of gives you a breakdown of the usage of their network over, looks like 5-minute averages over a day, over a week, and over a month. If you look, this is daily. You can kind of see a pretty consistent pattern each day. Over the month, it's a little different. And I can't tell what months those are, but I'm betting that maybe that's the end of the semester and that's a break or something. Just kind of a guess. Another dashboard, again, gives you different types of information. You used to be able to actually access this online, but for some reason they shut it down, so you couldn't access it externally. But you could actually see the performance of their network real time. Let's see, application layer protocols defining type of information collected in the format of control messages. These are those standard protocols I was talking about earlier. The oldest one is SNMP, and it's a standard protocol that's built into a lot of these managed devices that automatically sends information to some of the software that we were just talking about, and provides you information about the status of these various devices, how they're performing, are there any errors, and things like that. I will say SNMP has been around a while, and it lacks certain functionality that really a lot of network administrators want. And so that's why you start to see a push towards Common Management Interface Protocol, which is newer, provides you more detailed information about the status of a device, how it's doing, things like that. You've also got remote monitoring. Enables remote monitoring of SNMP devices, provide network-wide monitoring information to the manager rather than device-wide. So instead of looking at individual devices, we're looking at the performance of an entire network rather than the individual devices. So it's really going back to that idea of that dashboard. So it puts it all together to let us know this is how overall we're functioning. Then if you actually see a problem, you can start to drill down to the individual component that's causing a problem. And it collects it in various layers so that you can do that. Problems with SNMP, limited functionality, security. One of the problems that you see with standard networking protocols, Ethernet, TCP/IP, SNMP, a lot of these protocols were written back in the 70s, early 80s. They were designed before security was really a big concern. The internet, as we know it, was not around then, so you didn't worry about people hacking into things for the most part. It wasn't a big concern. IP version 6 is changing that, but it's taking time to shift over to that. So as far as an SNMP network, how it might be designed, you might have a switch, a managed device with an SNMP agent on it, and again, it can report it back to a server that has the software on it so that you can monitor it and see how that switch is performing. So it's a special router, it's a special switch that has that capability built into it. So it's not the kind of stuff that you're going to go buy at Best Buy or wherever. Something else managed devices allow you to do is policy-based management. This is what I was talking about a little bit ago when I said that you could, for example, restrict certain types of network applications at certain times of the day. Maybe you don't allow access to Facebook. Maybe you don't allow access to YouTube. Maybe you do at certain times of the day. Those are policies that an organization can decide on. My wife's a school teacher in Denton right now, a substitute teacher. And one of the things that they do is they restrict access on their network to a very few sites. And it makes it very frustrating in some cases when there's content out there that you know is there but you can't get to. But at the same time, it really limits what kids can do as far as the sites that they can visit. They can visit the school website, they can visit Wikipedia, they can visit some of the news sites, but they can't visit YouTube, they can't visit Yahoo, things like that.
So do they just block the address, or how do you?
There's a lot of different ways you can do it. You can block an IP address, you can block the web address itself. It depends on how you want to do it. And usually policy-based management usually has a lot of different, it's very granular. It allows you to create policies at a very granular level and have a lot of different choices. So for example, when you're here on campus and you have a device that has not been on a wireless network before, and the first thing you do is you find a wireless network, right? It comes up, and when you open it, regardless of your home page, it goes to the Tarleton guest page that says you need to log in. It does that through policy-based management, that it redirects your request to their server, and until you've logged in, you can't go anywhere else. And that's a policy that they've created on their network to be able to do that, so they control your access to their wireless network. Otherwise, they would have to share their web key with everybody or whatever type of encryption that they're using in order to lock it down, or it would have to be wide open to everybody. So that's how they do this, through policy-based management. Let's see. As far as the use of it, it's becoming more and more common. I actually bought at Christmas. I bought a cheap wireless router just because I needed one, and you're starting to see a lot of these types of features built into low-end routers. For example, that router that I bought, it had that capability in it, that you had both a secured wireless network, but you could also create a guest access to it, so that when that part of it's unsecured. When somebody saw it, they could type in a password into the guest account and then have access to the network, which I thought was a really neat feature. But that's something that before you really saw limited to higher-end equipment, much more expensive equipment. For $25 for something Something from Walmart, that's a good deal. I should have bought more of them. Black Friday, I'm telling you. Network circuits play a critical role in designing network for maximum performance. Important to size the circuit and place them to match the traffic. You just do the best you can because you're going to be wrong. But you want to do the best you can. You want to typically err on the side of having too much capacity because it will get used. That slide earlier talked about reaching capacity within 3 years most of the time. You're going to reach that capacity. No matter how much extra capacity you build in, you're going to reach it. It's just a question of how long before you do it. Areas of concern, circuit loading and capacity planning, traffic analysis. Why are some circuits more heavily used? That's something you can spend a lot of time on looking at, and it really depends on how badly you need that answer. They have packet sniffers, things that you can hook up to different segments of the network and watch the actual contents of the packets as they go across the wire. But unless it's, again, unless it's an environment where you really need to know what traffic's going, if it's a situation where it's law enforcement or a situation where you really need to know, you can certainly do it. It's just not feasible in a lot of cases. Service level agreements as well. You want to make sure that your service level agreements are being met. Most of the time when it comes to service level agreements, one of the issues that students seem to have trouble with is when we talk about service level agreements are worst case scenarios, not best case scenarios. So when you hear this idea of a service level agreement, it's not a case of we're going to get a 2 meg download from our WAN connection. It's a case of we're going to get at least 1.5 meg, something to that effect. So it's not a case of we're going to get on the high end of things. It's the low end of things, and if they go below that, nobody complains that it's supposed to be 2 meg and we get 4. Nobody ever complains about that. But if you get 1.8, that's below your service level, or 1.3, that's below your service level agreement. Then they violated the agreement. You then need to go back and look and see what are the repercussions. Is there a penalty that they pay? Is there a free month or whatever? But you have to monitor your network to be able to know that that's occurring. Traffic analysis performed to pinpoint why some circuits are heavily used. Again, if you happen to have a server over here in Atlanta and somebody over here needs to access it a lot in Vancouver, it's a long, not only is it geographically a long distance, but there's not a direct connection. It's having to go through Toronto. It's having to go through Dallas. It has to go through San Francisco. It's having to go through an extra hop to be able to make that. Well, if that's a heavily if there's a lot of traffic that goes back and forth between those two sites, maybe it's worth investing in a direct connection. Maybe it's not. You have to make that determination. If it's not, maybe there's another solution. Maybe you replace a switch with a faster switch, or you add more bandwidth this way. Maybe it's cheaper that way. But you have to know where the traffic's going so that you can make that determination. And that's part of the reason for traffic analysis. They have their own example there. Service level agreements established between organizations and common carriers and ISPs specify the exact type of performance that common carrier will provide. They give you, typically they'll give you a couple of criteria. They'll say not only a certain level of performance, but also a time period that's associated with that. So if they're going to say we're going to be up 99.9% of the time, we're going to be up 99.9% of the time to this degree, 1.5 meg or whatever it happens to be. So it also includes maximum response time and other parameters. Specify penalties if the desired performance is not provided. So just because they say they're going to be up 5 nines or 99.9% of the time, that's good, but you also need to know what the penalties are. I mean, if there's no penalties, what's the point in having the service level agreement? It doesn't mean anything. So there needs to be some type of criteria with respect to penalties. How do network devices impact performance? Some are faster, some are more reliable. Usually cheap routers, off-brand routers, switches, etc., there is a performance hit. They're not as good. At the electrical engineering level, the specific transistors that they use, for example, are of less quality. They're not as fast. They don't switch as fast. And when you start talking about large volumes of data, that results in latency and delays. Device memory is also an issue. Some devices simply pass through packets. They don't slow down at all. They're operated at the speed of light, or virtually at the speed of light. Whereas others actually have memory that's built into it. That memory will slow things down. So that's one of the things that can impact performance. Load balancing is a capability in sharing the network load. So if you happen to have if you have one server that is really under a heavy load, a lot of cases you can have a second server that comes online and helps to share some of that load. So, for example, you ever wonder why you type in www.microsoft.com? Well, there's probably 10,000 users on their server at any one time. One server can't handle that. Well, it's because they don't have one server. They've got multiple servers that are balancing that load across them and responding to those various users' requests. And it's a way to be able to handle a lot of simultaneous users at the same time. And then capacity management. Capacity management is the idea that you want to manage when users can be on the network. So maybe you don't allow printing of certain types of documents throughout the day. You don't allow printing of pictures or files over 50 meg or something like that. You're controlling the capacity and trying to shift it to other parts of the day where demand isn't nearly as high. So printing of large files occurs at 6 and after, things like that. So it's a way to try to manage the capacity of your network. As far as device latency, latency is a delay in your packets getting from point A to point B. If your devices happen to be that you're using, your switches and routers, etc., poor quality, or they're failing, or the distances are large, that can create latency. Most of the time it's not a problem. You know, if you send an email, if part of that email gets there a couple of seconds later, it doesn't impact that email at all. You get the email a couple of seconds later, the client puts it all together, rearranges the packet so that they're in order, and your client shows you that you got a message and you can read it. If you have latency built in, latency in communications with respect to video or Skype sessions or something like that, even then, as long as the latency isn't too much, it's not that big a deal. It leads to a little bit of a delay, but you can still communicate. What happens though, is you sometimes, something that's related to latency is something that's called jitter. And jitter refers to having an inconsistent latency, where this packet is more latent than another packet. So that inconsistency, now all of a sudden you end up with jitters in the voice or jitters in the video, and that's not acceptable. Again, jitters with respect to email, not that big a deal. With respect to video and voice communications, it can be a problem. Key element affecting latency, computer processor in the device, the distance, the devices that are being used, and the applications on both ends can contribute to latency. More important for networks with heavy traffic, high latency devices may cause long traffic backups. Less important in low traffic networks. If you don't have a lot of traffic, usually latency is not a big problem. Just kind of how it works. As far as device memory, it goes hand in hand with memory. Again, those packets show up to a switch and end up pausing there for just a second, and that creates latency. And when I say just a second, it's not like a full second, but 125 milliseconds, and you can end up with just a little bit of a jitter. High latency device backed up packets to be stored in memory. So the good thing about something like that, having memory in a device, is that it allows, as the network starts to become congested, it allows you to kind of control the flow of those packets as it's going through that particular switch. That's the plus side. You're not dropping that packet, which then has to be resent, which then creates more congestion, so you don't end up with that type of situation. But you are creating a situation of having latency in your network. Also important for servers, more memory means more files can be stored in memory. Requests processed more quickly and often faster than hard disks. the idea of load balancing to ensure that a request is handled immediately by a free server in the server farm of clusters. So when you go to access a particular server, let's see, say these are all servers right over here. Something comes in, actually we've got a load balancer here. Something comes in from the outside. We've got some kind of device. In most cases, it's a server that makes a decision with a specific type of software on it that basically says, all right, I'm keeping track of all these computers in our cluster here. This one is really busy. This one's really, all these are really busy except for this one down here. I'm going to send that request to that one. All these computers see the same stuff. They're all using the same database. They're all using the same web server. So all the information is exactly the same. But all these other ones are busy serving other requests at that particular moment. This one's keeping track of every computer in that particular cluster and says this one is free. Let's send that request there. So it creates a lot of work for this one too. But it's not serving, its type of work is busy work. It's able to process those types of requests really quickly. The advantage on something like that, your workload, you can handle a lot more work. If you happen to have a server that crashes, this one crashes, you'll go find another one that's not quite as busy as the others. So it gives you a lot of redundancy in that particular network. The downside to it is, if your load balancer goes down, all of these are down. So you've got a central point of failure. So in a lot of cases, you'll actually have more than one computer that serves in that function as well. Capacity management, use capacity management devices, also called bandwidth limiters or bandwidth shapers. Slow down users who use too much capacity. There's some talk about that here a while back on some of the cell phone usage, the data plans, that I don't remember which carrier it was. They were promoting unlimited data plans on their cellular network. That was true, but what they were doing is once you hit a certain level, they were slowing down your access, and it really only affected a very small percentage of their users. The idea was that it was to try to punish them for using too much bandwidth, and if it slowed down, then they'd stop using it as much once they hit that limit. And it's basically a way to try to reserve some of that capacity for other users that aren't consuming quite so much. You can install those in key points throughout the network and limit capacity really kind of however you want to. Kind of depends on the device, the software, what you can limit, but in a lot of cases you have a lot of functionality. There's a lot of things that you can limit. You can limit protocols, you can limit ports, you can limit all kinds of things. An example of that type of software. Minimizing network traffic, another approach to improving network performance. Attempts to move most commonly used data closer to the user. That's where you might have that cache server, for example, that we were talking about earlier. A cache server where you go out and you hit your local server for a web address that's already been retrieved. It doesn't have to go back out to the actual web server. It's already got that cached page. The plus side is like I said, you have faster responses from your cache server because it's a closer connection. You have reduced demand on your WAN connection because the proxy server doesn't have to go out and re-request that page. The downside is what's the real advantage of the internet? It's dynamic. It changes all the time. Well, if that web page you access on your cache server, the original has been changed, you don't see that because you're seeing the cached page on your proxy server. So that's one of the downsides as far as that. There's certain techniques to try to minimize that from happening, but you have to be aware that that is a possibility, that you're actually looking at old content. So content caching, content delivery. Content delivery is kind of the same concept of content caching, except in reverse. I don't remember the name of it. There's a company, Akami or something like that. They basically operate in reverse, and what they do is they have their own web servers throughout the world, and they sell those web servers caching capabilities to various corporations, Microsoft, Yahoo, Google, etc., to locate content all over the globe so that it's closer to users. So instead of when you go to access a web page, instead of you going to your cache server, you actually go out to the internet, but you get directed to the closest one of their servers, and so you get a response quicker. So it's the same concept of content caching, but it's being facilitated in reverse. It's being facilitated by the web server's end rather than on the content user's end. Content caching, that's everything we just got through talking about. So this is kind of a graphical example. If let's see, user in Singapore requests a web page from Yahoo. Well, if Yahoo's web server's over here, that request has got to go all the way over there and it's got to come all the way back. If they've already got a web server here, if they place one of those, see if they show, yeah, Akamis. So if they actually have one of those servers there locally, instead of having to go all the way over there, the Akami server, once a night, once an hour, however often, they go back and they sync up their server with Yahoo, and then every request in this region, instead of doing this, it simply goes to that local server. It gets a much faster response, and it doesn't tie up all of this every single time there's a request accessing Yahoo. Benefits of content delivery: users of the web page of customers subscribed to Akami. Much faster response time because many parts of the requested page will come from a nearby Akami server. So the distance is much less, so the response is better. Customer organizations subscribe to Akami, so less traffic for its servers. Need not spend as much on its server farm. You don't have to have, as a business, Yahoo doesn't have to have as many servers because a lot of its requests are being fulfilled by Akami servers. And need less capacity on its circuits to the internet. ISPs providing service to users. Less traffic flows through their network, which is a benefit because much of this would be unpaid traffic due to peering. Peering is the idea that ISPs don't charge each other for internet access, which must be nice. So this chapter, implications for management. Develop strong relationships with only a few vendors. That's kind of a mixed bag. If you develop just a few relationships with just a few vendors, as long as that vendor's around, you're in good shape. But if they go out of business, you're kind of stuck. You've got a lot of equipment that's no longer supported. But at the same time, if you've got that strong relationship with those vendors, usually they'll do a lot more for you. They'll work with you a lot more because they know they've got a lot of investment with you, and that if you leave, that's a big account that they're going to lose. So they usually a lot of times will really try to work with you. Purchase technologies that will provide strong network management capabilities. The ability to manage your traffic, to know when a particular circuit is failing or a particular network card is failing, is really, really valuable. It's really nice to be able to show up and replace something that's failing before it's failed completely, before a user realizes that there's a problem. Or to be able to have an answer before you start getting help desk calls. It's nice. So if you've got some of those network management capabilities as an opportunity, try to take advantage of that. Use powerful design and management tools. Things like Microsoft Visio, some of the other design tools that are out there. Absolutely use them because it really helps you to convey your design initially. It also allows you to change it on the fly. If something comes up, you're able to go back to that diagram, make a modification, and document what's going on in your network. And documentation is something that's traditionally very weak, but at the same time can be very powerful in knowing where your lines are running, what the capacity is, the types of equipment. That documentation, which is really kind of what our project is in here, that documentation is really important. So that is it for that chapter.